Question 2, they've used the two dot notation there, x double dot equals minus 16x. So that's telling you the acceleration is proportional to the distance there. So we have this simple harmonic motion again there. Let's rewrite that as d2x by dt squared plus 16x equals 0. And the auxiliary equation of this will be m squared plus 16 equals 0, which gives you m is plus or minus 4i. So the general solution is a cos 4x plus b sine 4x. Not x, t there, because we're in terms of t now then. Is that? Find out what we've got there then. If we differentiate that, we're going to get minus 4a sine 4t plus 4b cos 4t, and we've been told that at t is equal to 0, x is equal to 5. So that gives me 5 is equal to 0 in there makes 0, 0 in there makes 1. So we've got a equals 5. And we're told at t equals 0, the velocity, or x dot, is equal to 2. So that's 2 is equal to, well, that's all 0 here then. So that's 4b. So I've got b is equal to a half. X is equal to 5 cos 4t plus a half sine 4t. And part B, determine the period and the maximum distance the particle is. So again, like last time, we're going to rewrite this in its harmonic form. So I'm going to use an r sine. Should we use a sine? I'd rather use a cos, but just think a second. No, I'm sorry. I'm going to use a cos because I know the formula book. I know the answers using a sine, but I'm going to do 4t minus alpha here. Expanding that gives me r cos 4t cos alpha, minus here gives a plus r sine 4t sine alpha. So it tells me r cos alpha equals the first one 5, and r sine alpha equals the second one a half. And r is equal to the square root of that squared plus that squared, 5 squared plus, and the square root of that gives 101 over 2, square root of 101 over 2. And so look, that is the maximum displacement it's going to be. I'll just finish that off. That this whole thing is equal to root 101 over 2 times by the cos of 4t minus, and I've done an inverse tan of a half over 5 here as well, so that's 0.0997. So the maximum it's going to be here. Oh, and the other thing it's asked for is the period it takes, isn't it? So look, we've got a 4t here. So how long does a 4t take to go back and forth? So it's doing 4t in 2 pi. So the time is equal to pi over 2 is the time taken to go through one oscillation of the motion.